Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Technology. Now we are going to see about the input-output system management in operating systems. First one, we are going to see about the recap, that is last class lecture series. Next one, content delivery, and then see about the real-time examples, and then we have a brainstorming sessions, and then a fourth one we have the real-time DT-based case study delivery, and then we have the assessments. In recap, last class we see about the input systems overview. There we seen that hardware systems, software systems, and the data transfers, and then device controls. Here we have the diagram for that session. We have CPU, input output devices, and the memory. CPU, it gives that input output commands to the input output devices. From that input output devices, it communicate with that memory, that is data. In data, it communicate, and then it communicate with that CPU. Next one, input output system components. Here we have the five types, that is input output devices, device controllers, device drivers, input output interfaces, and then interrupts. Here we have CPU, memory controller, video controller, keyboard controller, USB controller, disk controller. It is connected with that common system bus. In memory controller, as usual, it have memory. Video controller example, that is monitor. Keyboard controller is keyboard. USB controller, it may be USB drive, anything. And then disk controller, it connected with the disk drive. Next one, real-time examples of the input-output devices. Keyboard, it is comes under input devices. Printer comes under output devices. Hard disk, and then network communication, and then USB devices. These are the real-time examples that we are using as an input-output devices. Next one, case study. The problem statement is to design an efficient input-output system that ensure the fast, reliable, and seamless communication between the operating system and then external devices. This is the real-time case study. We have to empathize from this case study. We conclude that here we gain the points as user experiences, device interactions, and then performance need. From this empathize, we get these 3 points, and then define state, we get an idea about the speed and the reliability and compatibility of the particular devices. Third stage will be the ideate stage. In ideate stage, we get an idea, that is buffering, interrupt handling, and then direct memory access. Fourth one will be the prototype state. In prototype state, we can apply the input output model and device drivers simulations, and then data flow design. We can apply these models in that problem statement. Fifth one will be the testing state. In testing state, we have that we can increases the response time, and then error handling and throughput. These are that from testing state we get an idea. Next one will be the assessment. In here we have the three assessment. First question will be that it acts as a bridge between the hardware devices and then operating system. Which devices that is? The answer will be the input-output system. Here input-output system is act as a bridge between the hardware devices and then operating system, because it gets the data and it will communicate between the hardware devices and then operating systems. Second question will be, I can translate the user commands into the signals that devices can understand. That is device drivers. Here in system storage management, device drivers are used to translate the user commands into signals, because the system can understand only the signals, so that the device used will be the device drivers. Third question will be that I can handle the data transfer between the memory and the devices without the CPU involvement, that is direct memory access, because it won't take the data to the CPU. It can handle the data transfer between the memory and the particular devices. It may be the printer or a or that monitor, that is so it transfer the direct data between the memory and the particular devices. That is called as a direct memory access. Thank you.